Alright, data structures fans. Today we're going to do a little exercise in binary tree traversal, and we're going to do it recursively because that's the easiest way to do it. So first, using these numbers right here, I'm going to quickly build a little binary tree. 17 is my first number, so it's going to be the root. 17, he goes there. 19 is greater, so he goes to the right. 12 is less, he goes to the left. 18, bigger than 17, so we go right. Smaller than 19, we go left. 30, bigger than 17, bigger than 19. So we take these two right branches and we put him there. 15, row, less than 17, so we go left. Bigger than 12, so we go right, like that. And then 2, less than 17, less than 12, so we go there. So there we go. We have our little binary tree. He's set up real good. Now, what we want to do is traverse this thing and print out the numbers from low to high. So that means we want to start over here. So I'm going to scratch out a little bitty traversal. It's called an inOrder traversal. It's going to make 2 recursive calls. So pardon my big clubby hand. Hang on, here we go. Void. And, oops, I'm going to use a big O. inOrder. Tree node T. Like that. So notice all the small numbers, we find them by going left. So that's the first thing we're going to do, is we're going to try to go left. If t dot left does not equal null, here's where I make my first recursive call. inOrder t dot left, like that. If I can't go left, I'm just going to print out the number. So here we go. Print t dot data, like that. Now I'm going to try to go right. If t dot right does not equal null, inOrder t dot right. I don't know if you can see all that. There it is. So that's it. Now look, this piece of code will print out all of these numbers. This is a pretty simple piece of code, or put it this way, it's deceptively complicated. Simple looking because it only has a few lines, but what it can do is pretty awesome. I'll try to just quick review it. If I call this guy with the root, look at this sequence right here. It's going to recursively call itself and follow this branch right here. Once it stops here, this is actually null right here, right? Once it stops here, it can't go left anymore, so it's going to print this out. So it'll print out the 2. Then it's going to try to go right. Can it go right? No. Let me get that a little better for you. So it can't go right. So that version of the traversal of this routine will end, and we will return to the one that called it, which was a left branch, and we'll print the 12. I want to go over the calling sequence, and I'll do that on my next page. Hang on. here's the thing. We got to watch out here. It's easy to make a mistake here. The code's correct. We don't want to have a a mistake in how we think this thing is working. No bugs in this code. Oh, there's a bug. Hang on. I got him. Ew. Well, sorry about that, folks. Oh man, that was our good bug. He kind of made a little bit of a mess. Got rid of him. Clean him up a little bit. I think the last time we smacked this bug, he bled red. That time he bled yellow. What's up with that? I don't know. All right, y'all. Here's our code, and here's our tree that we had from the previous page. So what I'm going to try to do right now, if I can keep this thing in focus for you, is I'm going to go through the calling sequence. So we're going to call this with the root. So I'm just going to call it like this, inOrder 17. I'm going to write it like that for you. Now, when on that call, when we first go in, we say, can we go left? And the answer is yes. So we're going to make another call. So I'm just going to write like this, inOrder 12. inOrder 12, we'll say the same thing. Can we go left? The answer is yes. So we'll call that one inOrder 2. Now, in inOrder 2, can we go left? The answer is no, just like we said a minute ago. So if we can't go left, we come to this statement right here and we print out the 2. I'm going to write that 2, maybe right down here so you can see it. So we print the 2. As soon as we print the 2, we try to go right. We can't go right. So what happens? This version ends and returns to who called it, which was inOrder 12. Now, inOrder 12 called it from this position right here. So inOrder 12 will now print the 12. So I'm going to write that right here, 12. And now it's going to try to go right. It can go right. So I'll write it, I'll make this, I'll write it down right like this. inOrder, was that a 15? Now, it's going to get messy over there, I can tell. So on inOrder 15, what's going to happen? It's going to try to go left right there. Can it go left? No. So it's going to print the data. So I write down my 15. Now it's going to try to go right. Can it go right? No. It can't go right. So it's going to end, just like the 2 did. So it ends. It's going to return to inOrder 12. It got called from right here. So inOrder 12 ends. So I can cross him off. When inOrder 12 ends, he returns to inOrder 17. inOrder 12 was called from this call right here. So now the next statement is this print statement. So we go to the 17, just like that. Now, we're here in inOrder 17. So the next thing to do is to try to go right, which we can do. So I'm going to try to do this like this. And we'll write down inOrder 19 like that. So in inOrder 19, we come in here and we try to go left, which we can do. Oops. Let's do that. inOrder 18, there, like that. inOrder 18 tries to go left. It can't go left. So it comes to this print statement. So we print the 18. After the print statement, we try to go right. We can't go right, so inOrder 18 is complete. Now, when it completes, we return to inOrder 19. inOrder 19 is actually right here, so we're going to go down to here and print this data out. So there we go. So after we do that, we've printed our data and we're going to try to go right. So we make this call right here. inOrder, oh my god, I can't fit it. inOrder 30, what is that? inOrder 30. When we go to inOrder 30, we try to go left. We can't go left. So we print out the 30 from this call here. We try to go right. We can't go right. So he's complete. We return to the 19. Now, when we return to inOrder 19, we're returning to this call here. So 19 is complete. So now we are going to return to inOrder 17. We're returning from another right call. So inOrder 17 is complete, and we have completed our traversal. This thing works pretty good. The way to understand this is to kind of trace through a couple of these trees. I highly recommend it. Thanks for watching. Oh, one other thing. I wanted to make one comment about the corona thing. Please do your very best to follow the guidelines. This is a no joking thing, and please be careful and stay healthy. Thank you.